Hello dear students, this is Zameer Shaikh and today we will see applications of differential equation to electrical circuits. So let us proceed for the examples based on applications of differential equation. We have already seen that there are three parameters of an electrical circuit which includes inductance L, capacitance C and resistance R. So first of all, we have to make the differential equation of an electrical circuit, and then we have to follow the basics, that the basic method that one should follow to solve the differential equation based on electrical circuits. So let us proceed to see how we can make the differential equation from the given examples of electrical circuit. So first we will see how many parameters are there for an electrical circuit. So there are three parameters, that is inductance L, it is called as inductance. Inductance is represented by the symbol L. Capacitance C and resistance R. So these are the parameters of an electrical circuit. Okay, and EMF E. EMF E is fixed for any electrical circuit. EMF E is fixed, that is electromotive force. So how we can make the differential equation of any electrical circuit? So for that, one should know the voltage drop across inductance L is L di by dt. The voltage drop across capacitance C is Q by C. The voltage drop across resistance R is RR. So these three things we have to remember. For inductance L, L di by dt. For capacitance C, we will use Q by C. And for resistance R, we will use Ri to prepare the differential equation of the given electrical circuit. So let's proceed. If I ask you, write down or state the differential equation of LR circuit. If I ask you, state the differential equation of LR circuits. So how we can write down the differential equation of LR circuit? So for L, we will use L di by dt. We will put plus sign. Then for R, we will use Ri, and then it is equal to EMF E. Right hand side is always fixed. Just we have to put, for L we will write L di by dt, and for R we will write down Ri, and right hand side is always fixed, that is EMF E. So in this way we can make the differential equation of LR circuit. Similarly, if I ask you what is the differential equation of LC circuit, if I ask you what is the differential equation of LC circuit, so for L we will write down L di by dt. For L we will write down L di by dt. Then we will put plus sign. For C we will write down Q by C. If I use small symbol Q, Q by C, and right hand side is fixed, that is EMF E. So this is the differential equation of LC circuit. In the similar way, if I ask you what is differential equation of RC circuit, what is differential equation of RC circuit? So we will write down like this. For R we will use Ri, then we will put plus sign, and for C we will use Q by C. So here I am writing small q upon C, and right hand side is E. And finally, if I ask you how we can make the differential equation of LCR circuit. LCR circuit, differential equation of LCR circuit. for L we will write down L di by dt plus, then for C we will write down Q by C, and then for R we will write down Ri, which is equal to E. So we can observe here right hand side of each and every differential equation of an electric circuit is fixed, that is E. EMF E is fixed. Only we have to observe the parameters, that is inductance L, resistance C, and capacitance C, and resistance R. Out of these three, which parameters are given? Which are the things are given, or which are the things are asked? For example, as we have taken here, if LR is given, then we have to use L. For L, we will use L di by dt. For R, we will use Ri, and right hand side we will fix it, that is E. In this way, we can make the differential equation of any electrical circuit. Now we will proceed for one of the example based on electrical circuit. This is one of the example based on electric circuit. You will see here a circuit containing resistance of 20 ohms and inductance of 10 henries is connected to 100 volt supply. Determine current after 2 seconds. So here we have to find out the current after 2 seconds, means here we have to find out what is the value of current I after 2 seconds. So first we will list out the things which is given in the example. We'll write down, given that here resistance is given. Resistance is represented by the symbol R. It is 20 ohm. Then inductance L is given, that is 10. L equal to 10, and then it is connected to 100 volt supply. So keep remember, 100 volts is nothing but the value of E. So E equal to 100. So these are the things which is given in the example. Now on the basis of these things, we have to prepare a differential equation, and then we can proceed for the solution. So now see here R and L is given. Obviously E is fixed for any electric circuit. E is always given, but out of LCR we have to observe which things are given. Out of LCR, L and R are given. Okay, so we have to use here LR circuit, or we can say RL circuit. I will write down LR circuit. Okay, this is nothing but the same. So here we have to use differential equation of LR circuit, and we will find out the solution. Okay, so here I will write down, we know that differential equation of LR circuit is given by so it is for L we will use L di by dt, then we will put up plus sign. For R we will use Ri, and right hand side is fixed, that is E. Okay, now we have to solve this differential equation completely, and at the end we will put up all the given values. As all the values are constant, R is 20, L is 10, E is 100. So we will put up all these given values at the end after the solution of this differential equation. Now we will solve this linear differential equation. We can observe here this is linear differential equation. So we will use the method of solving linear differential equation. Like first we have to find out its integrating factor, and then we will proceed for its solution. So first of all we have to convert this into linear differential equation. So for that, first we will divide with dividing throughout by this L, dividing by L to convert this differential equation into linear form. So first we will divide throughout by L. So I will divide each and every term by L like this, and this L and this L will get cancelled. So what remains, it is di by dt plus, I will write down this I on this side, So this becomes R by L into I equal to E by L. E by L. So now this is the linear differential equation which is in the form of we have to compare this differential equation with di by dt plus pi equal to q. This is linear differential equation. So here we can observe that the value of p is r by l, the value of q is e by l. So here we will get p equal to r by l and q, that is right hand side, it is equal to e by l. Now in the next step, first we will find out integration of p dt, as dt is there. So first we have to find out integration of p dt. We have to put up the value of p here, that is r by l dt. This r by l is constant, we have to take it outside. So it becomes r by l into integration of dt. Integration of dt is t. Integration of dt is t. This is the value of p dt. Integration of p dt. And then we will proceed for the integrating factor. So as we know that integrating factor is given by e raised to integration of p dt. Here we will have to put up the value of integration of p dt as we have calculated earlier. So it is r by l into t. This is the value of integrating factor. Now we will proceed for the solution. The solution of this linear differential equation is given by, so as we have already studied in unit number 3, the solution of linear differential equation is given by, here I is there instead of y, I is there. So the formula is like this: I into if is equal to integration of q into if dt plus c. This c is constant of integration. Here we have to put up the value of if. The value of if is e raised to r by l into t. On the right hand side we will have to put up the value of q. As we can see here, the value of q is e by l. So that we have to put up there, e by l, and here into integrating factor it is r by l into t dt plus c. Now here the integration is with respect to t, so only we have to find out the integration of that term which includes t variable. It means this e by l is constant, so that we have to take it outside of that integral sign. So it becomes that e by l is constant, and taking it outside, then we have to find out integration of e raised to r by l into t dt. So to find out integration of this term, we will use this formula of integration, that is integration of e raised to ax dx is equal to e raised to ax upon a. Here we can observe that the value of a is r by l, and for x variable we will have the variable t. So we will replace a by r by l and x by t. So it is equal to I into e raised to r by l into t. On the right hand side it is e by l is into e raised to ax. A is r by l into variable x is variable t here, and the value of a is r by l. So it will be like this, plus c as it is. We can see here this l is transformed in the numerator. That l will be transferred in the numerator. So the next step will be left hand side is as it is, I into e raised to r by l into t, e by l. That l is transferred in the numerator, so it becomes l into e raised to r by l into t upon r plus c. As we know that this is one of the basic formula, that if the term is like this, then this c will be transferred in the numerator. So it will be like this. So that's why we have used this, that l is transferred in the numerator. So this l and this l will get cancelled. Here e by r remains, and that exponential term So we will write down like this: I into e raised to r by L into t. Now what remains here? E by r. E by r I will write down like this, and that exponential term in the multiplication, e raised to r by L into t plus c. This is our equation number 1. So now what we have done here, we have just solved this differential equation up to equation 1. Now what's the next step is, we have to find out the value of this constant of integration c, and for that we have to always use the initial conditions. Keep remember, initial conditions are always I equal to 0 and t equal to 0 for an electric circuit. Initially there will not be any current in the circuit, so that initial conditions we have to always use to find out the value of constant c. So in the next step we will use the initial condition. Initially I equal to 0 and t equal to 0. We will put up this value in equation 1 and we have to find out the value of c. So putting this value, putting I equal to 0, t equal to 0 in equation 1, we can all see here, I will put up here the value of I equal to 0, e raised to r by L into t is 0, e by r into e raised to r by L, t is 0 plus c. Now in the power we can see here, r by L multiplied by 0 is 0, so it becomes e raised to 0. In the right hand side also is r by L into 0 is 0, so it becomes e raised to 0. And as we know that the value of e raised to 0 is 1, any term raised to 0 is 1, so e raised to 0 is 1 plus c, 0 multiplied by any term is 0, so it becomes 0 equal to e by r plus c. If you multiply this 2, it becomes e by r, and then the value of this c becomes, if we transfer this e by r on the left hand side, we get c is equal to, means it is minus e by r equal to c, that is c equal to minus e by r. This is the value of constant c. Okay, you can see here we have just transferred this e by r on the left hand side to get the value of c. This e by r is plus, so after changing side its sign will become minus. Now we have to put up this value of c in equation 1, putting c is equal to minus e by r in equation 1, we get, see here I am putting the value of c. Here in equation 1 I am putting the value of c. That value of c is negative, that negative sign and this plus sign will become negative. So we will get the next equation like this. This is equation 1, we are putting this value in equation 1, it is e by r, e raised to r by L into t plus sign is there, okay, and here the value of c is minus e by r. This minus and this plus become minus, so it becomes e by r, e raised to r by L into t minus e by r. Now we can see on the right hand side e by r is common. That common term we have to take it outside, and what remains in the bracket, so it is e raised to r by L into t minus 1. So what we have done here, we have taken e by r common. E by r is common in both the terms, so that e by r we have taken it common, and at last what we will have to do, we have to just transfer this term in the denominator. As this term is there in the multiplication on the left hand side along with I, so that term we have to transfer in the denominator, so that we will have to get the value of current I. So I is equal to, it is e upon this e raised to r by L into t into r is there into, in bracket, e raised to r by L into t minus 1. Now in the next step, we have to just take this term inside the bracket. Only this term we have to take it inside the bracket. So it will go in the denominator of both this term. So next step will be like this. I is equal to E upon R will be like this. Only we are taking that exponential term inside the bracket. Only take that exponential term inside the bracket. So that term will go in the denominator of both the terms. Like this. So we are taking that term inside the bracket. E raised to R by L into T. Now this, both the terms are same. This term and this term will get cancelled. And finally we will get, it is E by R into in bracket. This term will get cancelled, so it is 1. Now this term will be transferred in the numerator. So its power is positive. After transferring in the numerator, it becomes minus R by L into T. Its power will become negative. When we will transfer this term in the numerator, its power will become negative. Now this is our equation number 2. So now we have find out the value of current I after putting the value of current, after putting the value of constant C. So after this we have to put up, after this step we have to put up all the given values of E, R and L and also the value of T in this equation 2 to get the final answer. So now we will put up the values given. So what are the given things? R is 20, L is 10, R is 20, L is 10 and the value of E is 100. So all these values we have to put up in equation 2. And also we have to find out the value of current I after 2 seconds. So this is nothing but the value of T. This is nothing but the value of T. So here also we have to put up the value of T as T equal to 2 seconds. So now we will put up all these values in equation 2. So it becomes E by R, the value of E is 100 upon R, R is 20, E by R, E is 100, R is 20 into in bracket 1 minus E raised to R by L, R is 20, L is 10 into T, T is 2, bracket close. Now we can see here if we divide 100 divided by 20 it becomes 5. Here also we will do the calculations. If we solve this complete power term, it becomes minus 4. You can see here if I cancel this 0 and this 0 and if I multiply this 2 into 2 is 4, so it becomes e raised to minus 4. And now in the next step we will use the scientific calculator to get the value of e raised to minus 4. So by using scientific calculator we can easily find out its value up to 3 decimal places. Its value is 0.018. So we can find out its value up to 3 decimal places. The answer is sufficient up to 3 decimal places. So that's why I have taken e raised to minus 4 as 0.018. So by using scientific calculator we will get its answer as 0.018. Now the subtraction of these two, after subtracting 1 minus 0.018, we will get it as 0.982. 0.982, and when we will multiply this both the term, we will get the final answer as 4.910. This is the required value of current I. Its unit is ampere. So in this way we can solve the example based on electrical circuits. So once again we can proceed, we can see the process, the complete process. It's very easy. Just we have to observe what are the things given out of this L, C, R. We have to just observe the things out of which this LCR is given. Here we can now see that L and R is given. Obviously E is fixed. E is fixed for each and every differential equation. So we have to only see that out of LCR what is given. So here we can see it is LR is given. So we have to use the differential equation of LR circuit. We have to solve that differential equation completely along with the value of C, and at the end we will put up all the given values to get the final value of current R, that is 4.910 ampere. Hope so you will like this video and you have understood how we can solve the examples based on electrical circuit. Thank you.